One of the first things students are taught in geology courses are that three types of rocks exist: sedimentary rocks, metamorphic rocks, and igneous rocks. However, what isn't as often taught in the same lesson is the fact that sometimes a rock can break these categories, such as this specimen shown in the background. But more on it later. Here are brief definitions of these three rock types and how you can identify them. The most common rock type on Earth are igneous rocks. Igneous rocks can form directly from the movement of magma, which can solidify underground, volcanic eruptions including the eruption of lava, or the melting of a pre-existing rock. Magma, which by definition remains underground, creates intrusive igneous rocks which have larger crystals due to having more time to cool than their extrusive rock counterparts. This is how granite and rhyolite have the same composition but different appearances due to relative sizes of the crystals each contain. Igneous rocks can contain vesicles or small gas bubble holes in a rock and often have random crystal orientations. They also can have two crystal sizes present and can have a glassy texture such as with obsidian. Common minerals found in igneous rocks are plagioclase feldspar and alkali feldspar, olivine, pyroxene, quartz, amphiboles, and biotite. Next, sedimentary rocks, which are the most common rock type exposed on the surface of the Earth above sea level. Sedimentary rocks form when particles of rock, whether that be grains, larger rock fragments, and in some cases fossils, are compacted and cemented together. The identification of these grains, which often themselves come from multiple different source rocks, is a key identifying feature. Metamorphic rocks are rocks which are transformed by high amounts of heat and/or pressure, but the heat and pressure were insufficient to cause said rocks to melt. Crystals in these are often stretched and largely pointed in a single direction, and overall specimens are frequently foliated. Mica is also commonly present in metamorphic rocks, and rocks are often somewhat reflective at higher grades of metamorphism. A sugary texture is also a key trait of certain metamorphic rocks such as marble and quartzite. Now, sometimes by looking at a metamorphic rock, we can identify what rock type it originated from. If a metamorphic rock is completely composed of grains or fragments of sedimentary rock, then it is called a metasedimentary rock. In contrast, if a metamorphic rock is completely composed of grains of igneous rock, then it is known as metaigneous rock. Now, I had earlier shown this particular rock, noting that it did not fit any singular rock type. And that is because it fits two rock types, igneous and metamorphic. This is known as a migmatite. In a migmatite, a portion of the originally metamorphic rock with a lower melting point completely melted, becoming partially an igneous rock. Meanwhile, the higher temperature melting point areas remained unmelted. I hope that you found this video interesting. If you would like to request a specific topic, please leave a comment below. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.